traced back to the early 19th century when the French mathematician Adrien-Marie Legendre introduced the principle in 1805. However, Carl Friedrich Gauss laid a solid foundation in 1809. Least squares method is a mathematical technique to find the best fitting curve or line through a set of data points. It minimizes the sum of the squares between the data points and the curve. The goal is to minimize the overall error, providing more accurate relationship between variables. The purpose of this method is to get accurate data fitting which a representation of physical phenomena. Engineering systems complexity. Model developed enable the understanding of system behavior. These models help engineers make informed decisions, ensuring that the design systems meet performance requirements. As such, predictive models created enhance the reliability of predictions and contribute to risk mitigation. 3 benefits of least square method identified. First is accurate parameter estimation, where this method minimized the error between observed and predicted values. Example, it used to find the material properties. Second is error minimization, the sum of square residuals. Residuals means the difference between observed and predicted values. Example in system response. And lastly, this method is robust enough to handle noise data to provide reliable estimation. It minimizes the impact of errors through squared residuals, which yielding more accurate representation of trends. In least square method, there are 2 types of accessing the problems. One is linear least square, where the model is in linear function. It has a linear formula which I will explain later. The second is nonlinear least square, which this model involves nonlinear function. It has more complex equation compared to linear least square method. But both models have similar objective function to minimize the sum of squared differences between the observed and predicted y value. Objective function sum of the power of 2 observed minus predict y value. Of the least squares method involves fitting a line to a set of data points in a way to minimizes the sum of squared differences between the observed and predicted values or offset error. Vertical offset used in surface or polynomial and hyperplane problems, while perpendicular offset is commonly being used for any problems. And another way is through mathematical formula, which is y equals mx plus b, y dependent value and x is independent value. These values also known as observed value. M is commonly known as slope of the regression line and b is interception of the regression line at y-axis. For nonlinear least square method, the equation is little bit complex compared to linear modeling. In this method, the nonlinear modeling will be y equals a exponential b times x. I will share on linear least method problems where some tips is essential to remember to solve linear least method. Here are some tips before you start doing least square method. Make sure you make total error as small as you can. Imagine each data point connected to the line like a spring. Add multiply and power of 2 column for data given. Sum it and then you can start to calculate. Example data given in x and y as per in table. Follow the tips and start to do the calculation xy power of 2, then calculate slope, which is m value, and then intersect point, b value. Then complete your equation of y equal to m multiplied by x and add b value. Yeah. You are good now. From the equation, you will get a graph. Assume Sam expecting 8 hours of sun, then using y equals mx plus b, Sam will know he can sell 13 of y or 13 ice creams. It's easy, right? Now you can solve many problems. Now, let's talk about the limitation of the modeling. There are few limitations identified. First is outliers in the data can significantly impact the results. Large errors or outliers can have a disproportionate influence on the model parameters. Second is overfitting. This method may lead to overfitting, especially when there are noise. It may result in poor generalization to unseen data. The third one is by the assumption of linear relationship between the variables may result a poor fit if the true relationship is nonlinear. Fourth is normality of the residuals. This least squares may assumes that the residuals are normally distributed and departure from normality can affect the validity of statistical inferences and hypothesis tests. In the presence of limited data, this model can lead to an overly complex model that may not generalize well and misinterpreted due to the complexity of the modeling. We are about to end our discussion on least square method, and here are some of the thoughts about the modeling. Till then, thank you for watching and bye-bye.